All right, let's get started here. So happy Friday. I'll explain what we're doing here in just a second. I've got to warn anyone who's listening or now or later that it's raining here and my office has a skylight, and so it makes for, to me, somewhat loud rain noise. And I haven't recorded under these conditions before, so I'm not really sure what it sounds like to anyone else. So hopefully that's not too much of a problem. But I don't know. You've been warned. I don't do I do almost no editing on these, so whatever it is, even in the recording. Um, okay, before I get into the actual, let me always double check my audio here. Yeah, looks good. Okay, so before I get into actual content of what we are going to talk about and work on today, I just always like to mention the Open Web Foundry is still going. If you're building products on top of Arweave, I think today is actually demo day, so that should be an interesting presentation. It's right after this at 12 p.m. Eastern, 11 Central, translate into other time zones, as you will. So that is coming up, so just be aware of that. Just don't always do that, but I guess I might as well dump the link in the chat here. Actually, maybe my audio will be better because I'll be talking more loudly. So um, anyway, links in the chat there if you want to go to the Open Web Foundry. And let's dig in. So today it's a little bit of a divergence, I guess, from the sort of main line of distributed mining pool related development, but I want to dig into putting Arweave data, so like the actual, should be more specific. So the actual data I want to look at is the blocks and transactions, not the data that is recorded with the transactions. Taking that and then loading it into Crux, which is a database written in Clojure. You don't have to use it from Clojure, but it's written in Clojure, which is kind of why I'm familiar with it. And yeah, so I want to load it into there and do some experimentation with it. There's a bunch of reasons why I want to do this. I guess, yeah, I could show a little bit of stuff here too. So pool progress is coming along pretty well, and I actually have starting to have some analytics that I run on top of things. And right now, these are based on sort of event log data. So I'm just showing pool hash rate, which is very unimpressive at the moment, but it will grow. Miner count and that kind of thing. So essential pool statistics here. So right now, yeah, I'm just basing this on sort of event log data that I have. Eventually, all this is going to be on chain as well on Arweave. So a combination of transactions and tags associated with them, as well as data stored with the transactions. And so I definitely could use the GraphQL interface for Arweave to construct these. That, I think, is not going to be the most efficient way to construct these over the long term. And the event log, it's like I can't actually rely on people over the long term sending me events. I mean, I hope a lot of people do because it will help with error reporting and debugging, things like that. But they may just choose to not send those to me. But in order to participate in the pool, they have to put stuff on chain. So again, like I could query this directly out of Arweave's GraphQL interface, or I could read from the chain myself and index it myself. And I think that's what I want to do. It might not be worth it, except I think I have other uses for that too, which I won't go into now. But anyway, I generally think that if the cost of getting data into a structured format where you can manipulate it and query it in a very ad hoc way is low, gives you a lot of optionality in terms of what you can do with that data. And so that's part of what the path I'm pursuing here. I do have specific use cases that I have for it as well, but I'm not going to go into those in detail right now. Okay, so I should explain what Crux is. So like I said, it's a database written in Clojure. It has this very interesting architecture, which itself is actually a little bit reminiscent of a blockchain in a way. I mean, you can think of a blockchain just as an immutable log of events, which is also conceptually very similar to event sourcing. And the way Crux works is it basically, um, let's see if I can talk to this diagram here. So you have some sort of transaction log, and then you have a document store. And basically, things go into the transaction log as they occur and into the document store. Then there's an indexer that comes along and reads from both of these things and creates indexes based on the structure of the documents. Those go into the indexes go into indexes that are local to the database nodes, and then you can issue queries against them, and on demand, things will be retrieved from the document store. And I think there's a document cache too, otherwise performance would not be awesome if there wasn't a document cache. So I think the documents are cached as well. But that's the sort of structure of this, and this is actually, conceptually quite similar to how you might often use a blockchain. You can think the blockchain itself as kind of this transaction log. So, in a way you're duplicating the data, but you need to duplicate it for locality anyway. So, yeah, so it has some interesting properties. Let me see. Do they have good examples? Oh, they do. The Crux page here is pretty good. So you can think of the data store, Crux, the data store, as it's like a document database with data log queries, and the indexes are creating sort of column level. I mean, it doesn't exactly make sense in a document store to say that, but they're indexes of the individual attributes in the document. So you can efficiently query for like all the attributes for a document, or all the documents for an attribute, or I think all the values. Yeah, values for a given attribute. I'd have to look at the specifics, but it's basically kind of slicing up the document into these columns that are then the indexes that you can use to find and sort of materialize materialize a little over, is it sort of reify the values, retrieve the values, that's a better word, just retrieve the values for the document. And so you can do different kinds of queries. You can get a document by IDs. So this is an example of a transaction going into Crux, where this is the type of the transaction, and they're showing this in JSON. Doesn't have to be JSON, but I guess they're trying to be a little bit neutral here in terms of what technology you're using to send data in. So anyway, this is a put, so we're just going to put something into the database idempotently. So if you did multiple puts, it would result in the same thing. And you can retrieve by ID, or you could query on any of the top level attribute value pairs. And then the query language it supports is datomic flavored data log. So data log is like a restricted version of Prolog, which is very good for it's very good for graph traversals. But I mean, you can really do any kind of query with this. I think the vanilla data log these days is strictly less powerful than modern SQL. I think modern SQL may be almost Turing complete, because you can do you can do recursive queries, lots of SQL dialects. But anyway, it's basically equivalent, more or less equivalent power to SQL. There's a few things like windowing functions that are not going to be in this sort of out of the box, but that you can implement fairly reasonably on top of it. So anyway, traditionally data log looks something like this. It's very Prolog flavored. There's another database also from Clojure World where they implement a semantically equivalent dialect of data log. Let's see, atomic query example. Here we go. Wow, you have to scroll way too far on this page to find an example. Yeah, so this is where it originates. Datomic sort of created this data flavored. I think I'm unaware of a version of data log that looks like this prior to Datomic. So they created this sort of data flavored data log. It's semantically equivalent, but it uses a data structure to express the queries. And as we get into it, you'll see how this works. So yeah, they came up with this, and then lots of different Clojure projects, DataScript, Crux. Um, there's a few others that are slipping my mind right now, but there's a bunch of Clojure projects that have adopted this because when you're in Clojure, it's nice to be able to construct the queries out of data like this. You can do all kinds of manipulation and build them up. So that's where that originates. Crux just adopts it. It's more or less the same language. There might be some slight differences. And that's it. So the reason I want to use Crux is, one, I think it's a cool database. I've played around with it before. It's fun. I want to dig into learning it more. It's also, a document database with these data log queries on top is a very flexible default thing to put data into. Your other option, I think, that is sort of maximally flexible is just a traditional relational database. Like you could just throw all this data into Postgres and do a lot of ad hoc querying that way. But in some sense, I want to play with this setup, and I think there are some. Sorry, I think there are some kind of unique properties you get out of it too that you wouldn't. It's a very malleable way to deal with the data. Okay, so that's the context here. I've started playing with this already, so let's see, where did I leave off here? Yeah, so this is just a typical kind of Clojure project here. Don't think we're going to deal with schema stuff, so I'll just kind of throw this up here out of the way. So this is just a really minimal Clojure project at the moment. It's just a single namespace with kind of like minimal Crux bootstrapping stuff. And what this does when I do Crux start node, it just starts a local. I should probably put this. Actually, let me do this. Do a def once, so when I reevaluate, it doesn't redo that. Yeah, so this is just going to put a local, it's kind of in-memory CruxDB into bind it to a var in the local namespace. And yeah, I should go back to this diagram for 1 second. So one thing that's really cool about Crux and that this sort of inside-out database architecture enables is all these things can be implemented in different ways. So like here for the document store, you see they have Kafka, Amazon, S3, JDBC. You can use a lot of different things in each of these buckets. And one of the implementations of all of these things is in memory, and that just makes for really fast experimentation, which is kind of what I was getting at in the previous point of just having sort of a maximally flexible way to play with this. Typically, when you are working with data, you want to start with something like this, either this or like a very flexible relational database, and then as you figure out, you narrow down your use case if needed, you use a more specialized data store. But starting off with a more specialized data store is usually the wrong thing, especially at the current sizes. Like in the blockchain world, I don't think we're still dealing with really small data sets. And I don't think people who are coming into the blockchain space who don't have a background in dealing with databases or larger data systems don't, I think, fully understand that like the data sizes we're dealing with are trivial right now. Even Arweave, where there's all this data attached to the chain, it's like 10 terabytes. There's Oracle databases that are like actual relational databases. All the data in them compressed is an order of magnitude bigger than that. So we're still relatively early in the size of all these things, and you can put that data into all kinds of databases and do really interesting things with it. So yeah, okay, so let's see, did I restart my REPL? I did, cool. Let's load up this namespace. So I should have a node running. Let's see here, have some experimentation. Okay, so I have, yeah, I'm not sure if I want to do it this way. I have this sample blocks. Should maybe just call out random block. Sample is kind of misleading. Random block. Not really sure if I want to pull random blocks out of there or not. I probably just want to deal with a block. Let's do that. So I was looking at, yeah, this one's as good as any. So this is a block, just a random recent block I got yesterday. I should double check and make sure this is actually in the chain too, because sometimes reorgs happen. Arweave hash. That one? Yeah. Yeah, let's also do view. Oops. Oh, I should grab that's what I should do. I should grab the block height and just throw that in there. Yeah, let's do that. Height. Gotta prefix it. Okay. Okay. Curl this thing. Block hash. Thanks. Oh no, I didn't want to do the height there. Okay. This. Okay, yeah, same thing. Okay, cool. So that is definitely in there. So let's just do that guy right here. So I'm going to take the hash and put it into my REPL over here. Okay. Struggling with my X Windows copy paste here. Okay. So block to doc. So the way I think I want to store this, important things for storing data in databases is you want to make sure you have good locality for the kinds of queries you want to do. And in terms of dealing with Arweave data, most of the things you're going to do, you are not going to care about all this nonsense at the end. That's a proof that's showing that the miner has the data. It's necessary to validate the blocks, but for querying, this is not something you're going to care about. So I want to store the entire block, but I want to store the block metadata. Might need a better word for that. I'm not sure if metadata is the best. We'll start with that. But anyway, I want to store the block metadata and the entire block separately, so that when I retrieve the entire document of the metadata, it doesn't pull this 256 kilobyte chunk in with it. So this is just doing block to doc. It's looking at, let me go ahead and evaluate this and evaluate this one. Yeah. So we'll do this, which will submit the transaction. Then I'll run this separately. Depth to DB ID here. So the DB ID should be, and the way I think I want to index this too for like the document IDs. So the document IDs in Crux are the only thing I think well, I shouldn't say that. They're the easiest way to get sort of a unique constraint. So your document IDs are going to be unique in the entire database. Um, so for the blocks, I think I want to use the hashes as the IDs, and then the metadata, I want to use the height. So that means that when there's a reorg, um, the metadata will get updated, but the blocks will not. So you still have the pre-reorg blocks if you want to access them, but you won't have the metadata will get updated. I mean, it'll still be there in the original blocks too. That seems like the most obvious way to do it, or maybe the easiest way to do it. Maybe not the most obvious. So if I retrieve this, let's see, this is just doing a little bit of mapping. I'm going to get the body out, parse it as JSON, turn all the... Yeah, actually, before I go ahead and store this, let's just run this and see what that looks like. Although I am going to go ahead and dissoc the POA. Oops, other way around. Yeah, so I'll do that. So this will give me the block as a closure data structure with all the attributes converted into keywords, I hope. Okay, yeah. Pre-print that. Oops, really? Got my shortcut wrong there. Okay, that looks pretty good. Yeah, interesting. Yeah, well, let's just go ahead and throw that into Crux as is and mess with it. There's a lot of conversion I want to do. So all these things that show up here as B64U, those should be converted to bytes because I think there's like a 30% overhead or something for storing them as strings. And like every little bit like that matters when you're putting stuff into a database in terms of performance, because you got to think about when queries execute the amount of I/O they're going to do. And it doesn't really matter where it happens. Like it costs stuff. It costs. There's a cost of pulling stuff out of RAM. There's a cost of pulling stuff out of disk. Wherever you're pulling data, more compact representations are better. Assuming that you're not paying some big cost to do that. So I want to convert all these to bytes. Same thing with the weave size. There's a few things in here that are basically integers, but they're too big of integers to fit into the 53 bits or whatever that are safe to have in numbers in JSON if you're dealing with JavaScript. Let's say 53 bytes and then bits, whatever. They're too big anyway. But in Java in the JVM, there's arbitrary precision number types you can pull this into. And Clojure has direct support for that. So like if I do a 10n, that's an arbitrary length integer. I think m, if I remember right, is the decimal. Yeah, I think that's a big decimal. Oops. Yeah, no, it's n. That's like it's big int. Yeah. So anyway, we have good representations for those, and then when they're encoded into documents, they'll be in a more compact representation than a string of digits. String of digits has a lot of overhead because each of the characters is 256 bits, or yeah, I'm sorry, 256 bits. Each of the characters 256 possible values, 8 bits. Words, I can do words. Okay, so yeah, let's take this as is. So yeah, let's just run this and put it into the DB. I think I'll do the same thing because I don't really want to deal with the whole proof of access thing right now. Zips. Wow. So we'll just do. Also want to dissoc that as it's going. No. Oh no. There we go. Sorry. Emacs is trying to out-clever me here. I think I need to change some things about my Emacs setup, but it never seems like the most important thing to do. Okay, so let's do that as well. I think I'm just going to, for convenience, I'm just going to def the DB ID out here. Like this, and we know what the hash is already. So like that. Oops. Except it's a string. Okay. So I'll leave this binding here just to make sure, double check we get this okay. All right, so now if I do this, we shouldn't find anything, right? So I'm trying to retrieve the document from Crux before we put it in there. So, and if I do this, and the terminology I'm using here is out of Arweave getting blocks, and then we're converting them into documents because the Crux is a document database, so that's where the doc comes from here. Just to distinguish between like the original thing we get back and then the thing that we're munging a little bit to put into the database. Okay, so let's just run this real quick. Again, this will just print. Okay, so there's no proof of access in there. Good in terms of data size. And then we should be able to submit that as a transaction into Crux. Yeah, so we get transaction ID back. And now if everything goes well here, double check chat and streaming. Okay, cool. If everything goes well here, we should be able to retrieve. Yeah, okay, so that worked. Not super exciting yet. All we've done is just written this into Crux and retrieved it. So it looks identical to, or it should look identical to what we, I printed before. Okay, so let's run a query over it. So it's not super exciting, it's just one document, but we should be able to run some data log queries. So let me see, do they have an example of this? Because this is all on the fly here. I've used Crux before, but it's been a while now. Yeah, Clojure API, so that would be us. OpenDB, submit TX, open TX log. Where's the query? Okay, here we go. Query a Crux database. So we have take the DB and we take the query. This function will return a set of tuples if you do not specify order by, limit, or order by. That's interesting. They have order by in there. I wonder how that works. Well, anyway, stuff to dig into. One thing that's pretty nice about Crux too is the source code, especially if you have any experience reading databases in Clojure, like the source code is pretty readable and easy to dig into, and they try to make the abstractions pretty clean. Lazily query. Okay, that's cool. So you can do like streaming queries. Cool stuff. Okay, so let me just copy this as an example here. So we'll say def query, and then thing I just copied just to get us started. Okay. Oof. Did I get some tabs in there somehow? I think I did. Oh, and I'll need to quote this too, won't I? Yeah. So this is in Clojure, if I were to evaluate this, it would try to treat these things with question marks as bars and try to look up the values for them, but they're, in this context, they're not vars, they're just placeholders for things that we've filled in at query time. So what should we do here? Let's find the, well, it doesn't really matter. We'll just pick something. Let's find the hash. So we'll say H for our hash, and this will be interesting. Is there a placeholder? Can we just put a placeholder in there? Well, I guess we could just do B. I'm not sure if it will try to satisfy that. It might. Or maybe that. Well, I'm not sure what the syntax is. I don't actually care about what's here. I just want to look up for every single block with the hash attribute, what are the hashes? Oops, and question mark. Okay, so let's move this up here. So that's our entity, crux q, and database. So the way crux works is similar to Datomic 2, is when you issue a query, you're issuing a query against a value of the database at a point in time. As I'm saying that, I was like, I should have checked that to be completely sure, but I'm pretty sure crux and atomic are the same in this respect. You're issuing a value, you're issuing a query against the value of the database at a point in time, as opposed to against a connection like you do with a relational database you might be familiar with. That's definitely the case in Datomic. I'm pretty sure that crux does the same thing. The advantage of doing it that way is if you issue a bunch of queries against a value, you know that they're all querying the database at a point in time, as opposed to, as opposed to in a relational database, if you issue a bunch of queries against a connection, the database may actually be changing underneath you. And this is true even if you do things in a transaction. People don't always realize that, but in a relational database, unless you're using serializable isolation for your transactions, if you issue a bunch of queries in a transaction, you will actually see the data that gets committed during that transaction. All your writes to the transaction will either all happen or not, but any queries in there could be seeing multiple views of the data. If you have the value of the database at a point in time, everything you issue, every query you issue against that value will be using the same version of the data. I'm like, I don't know, like 85% sure that's how crux works. It's definitely how Datomic works, and that's one of the big value propositions for Datomic. And that works because the way the database works is it's treating your data as basically a progression of immutable values over a sequence of time, which coincidentally is very similar to how you have to deal with data in Arweave, because you can't change the past. You have to treat things as like the past is always there. You're just looking at a view at a point in time, which that can progress through time, but the past values are always accessible, which is good. Yeah, it's good to be able to reference the past. Okay, so now let's see. I suspect this will error on me, but let's find out. Yes, compiler syntax check. Is it because, yes, that would be just because I didn't evaluate that yet. Ah, okay, no, cool. So let's see, does it let me do this? Let's try that. Nice, okay. And I'm just going to put just for ease of iteration here, I'm just going to put the query right in line so I can mess with it. Okay, cool. So, and if we do this, oops. That also makes me wonder, I wonder how smart it is about this, if this does anything. Find first unknown variable. Yeah. So that's interesting. I think in Datomic, if I had done this, it would have complained that there's no binding for this, I think. Don't quote me on that. But I think this is probably a better way. So the way this is evaluating, it'll make more sense as we construct more complex queries, but the way this is evaluating is this is like, if you're writing some SQL, it'd be like select H from, this is a document database, so there's not really a great equivalent, but docs where, yeah, really just that, right? We're just selecting from all the documents. And I guess it'd be better if I did something like docs D and then select DH. So we're just using this condition here essentially to tell it what attribute to extract from the documents. It's nothing fancier than that. Maybe I'll keep this going just to show sort of the equivalent for people who are familiar with another query language. It's pretty intuitive. Basically, it's trying to unify and make everything that has the same name with these question marks be equivalent. And then if I do that, I guess Crux just treats the unbound stuff. So this is not being used in the output or used anywhere else in the query. It just treats that as like a wildcard. It could fill anything in. I think it's better to be explicit. Often in Clojure, when you're not using something, you're kind of treating it as a value that's just thrown away, or a placeholder uses underscore. And I think that's the idiomatic way to do it in Crux too, at least letting me do it. So that seems to make sense. Okay, so let's go ahead. I think next interesting thing to do would be to get some of these transactions in here, and then we can start to do some queries against transactions. So how to do this? Let's see. Let's go ahead, do this. Def tx IDs. So we're just going to work with the same block, and we'll take get this out of there. Tx is okay. So that goes well. I should get tx IDs equal to a vector of string transaction IDs. And again, I'm not doing it because I don't think it makes for super interesting streaming, but like all these should be converted to bytes, and that's ultimately what I'll do instead of storing the base64 URL encoded values. But the queries are going to look the same either way, and it's not like that's not super interesting to do in a stream. So okay, yeah, so that worked. I pulled out the transaction IDs. So now we should be able to do something like this, where we do like do seek tx. We'll stick with the tx ID to not confuse things. Tx IDs. So we're just going to iterate over those, and then in there, I'll just copy this whole thing. So in here, we're going to do basically the same thing. Actually, you know what? Doesn't really matter. I could submit these when I do this for real. I could submit them all in one transaction. For playing around on the REPL here, I don't really think it's important how many transactions I create. Okay, so we're going to want this to be a transaction, and I think if I remember correctly, there's only one way. Let's grab one of these. So, okay. I believe, yeah, my command, oops, oh, dang it. Yeah, okay. Okay, so let's do that. Oh, did I already grab that one? I must have looked at this before. Okay, yeah. So does it have, block? Okay, so it does not have, I think, the block in here that it refers to. No, it does not. Okay. So we will want to make sure we link all these to the blocks. I Okay, so anyway, let me get this going before I get a little bit ahead of myself there. So we'll just take this and tx. Oops. Ah. How many of these are there? Like how? $56. Well, let's do this. I'm just thinking a little bit about like what are we? We don't need to be hammering the server every time we want to retrieve those. Yeah, we'll just do it here. So we'll do like a take. Let's just do 3. We don't need that many to make it interesting. So take 3. So that's just going to take the first 3 TX IDs out of the sequence. Yeah. Okay. So let's see. We're pulling in the TX ID. All that's going to remain the same. Okay, and this is going to turn into the DB ID for a transaction will be Arweave TX, and we already know the TX ID, so we might as well put that in there. This is going to be the TX in this context. This is the same thing. We don't need to dissociate anything, so this can get pulled up and just associate the DB ID in there. We do, okay, I shouldn't have done that. So we do want to do, let's just call it block. So, and let's call this, let's see, oops, we'll call this block DB ID. So we want to take the block ID and where else do I have that? I have it there. So yeah, we'll call this block DB ID here. Okay. Yeah, and so we'll say the block is the block. Don't think I evaluated that yet. Okay, there we go. So just referring to the block DB ID, we already know. So the way this is going to work once it's less, less ad hoc REPL code here is that there'll be a loop where we grab the transaction and then, or grab the block, find all the transaction IDs on it, retrieve all the transactions, and create one. It gets a little confusing talking about both of these things. Retrieve all the Arweave transactions, turn all of that together into one crux transaction. So either the block and all the related Arweave transactions go in at once or not. And that will be, I think, a good granularity for loading things in. Okay, so I think this is right. So we're taking our transaction, we're putting a crux DB ID on there, and we're associating a block ID with it. So we should be able to join these things when we're all done. So I'll just do a sort of actually, let's do this. So I'll turn this from a do-seek into a for. So the do-seek is it's basically a construct for mapping. Well, mapping. It's not a great way to say it. It's a construct for looping over sequences and doing things that have side effects. And for is a construct for looping over things and returning the value of the thing inside the for applied to all of them. So if I just do this here, I should get a sequence of transaction documents out of here. Ooh, what did I do wrong? TX in this context, really? Right. It should be TX ID. I think my linter was telling me about that too, but I ignored it. Okay, cool. So let's pretty print that. It shouldn't be too bad, I think. Yeah. So right off, you see there's some stuff that we'll want to do to transform this. And I think ultimately too, in order to make the queries work well in Crux, you want to pull the tags out of the transactions too and turn them into separate documents that work to join the tags to. It's interesting to think about. I wonder if it would make sense. I wonder if it would make sense to actually have documents for each tag attribute type too. It might. I'll have to look into that. But at the very least, you're going to have a document that's like a join between um, the transaction and the tag name value pairs. So it'd be like transaction ID and then tag name and tag value um, as a separate document. But I don't know if we'll get there in here. I think just getting the transactions in there would be cool. We could do a join across all of those things. Okay, this looks like something we could load at this point, so let's try it. Okay, so I'm going to take this out and turn this back into a doSeq. In the real code, I will actually have something that's more for-like. It'll probably be a map that like maps over the transactions. Would it be a map? Because no, because there'll be side effects in there. I don't know. It will be a little bit different. I'll basically construct a data structure that has all the transactions in it at once instead of submitting them one at a time as independent Crux transactions. But let's run it, see what happens. Nil. Really? Oh, the doSeq probably. Does doSeq always return nil? doSeq. I thought it returned the last thing, but that might be wrong. One, two, three. So I'm just going to do this. I don't know if that succeeded the way I want. That's why you don't do side effecting things normally. It's hard to tell. It's hard to tell because I'm doing each of them independently. I probably would have thrown an exception if it didn't work. Okay, so yeah, so let's do this. So now we have, this is going to be a block. What's the best way to do this? No, let's start with the transaction. Yeah. Transaction to block. This would be B. And what do we want to pull out of the transaction? So what do we have here? Let's pull out the data size. So the same transaction. I'll explain how this query works in a second, assuming I get it right. I'll call this DS. Actually, let's just leave the block out of it initially. Okay, so we're going to pull out of all our transactions. I'll leave that actually as is. So if I execute this, I would expect to see 3 data sizes corresponding to the data sizes in here. Let's do it. And indeed, we got it. Just a comment about the format. It's a set, because we're going to retrieve unique things out of here. And each of the things in here is a vector because we could have, 1, 2, 3. We could have more stuff in here. So it needs to be a vector for each. You could think of these as rows or something in a result set. Makes me wonder what it does for order by. I guess it would return a vector because sets don't have any ordering. Okay, so now let's join to the block. And here we'll do the block. This is a silly query, but just to show you how stuff works. So the block will have the hash and that. So this is a pretty nonsensical query, but this will be joining the transactions to the block in theory. Yeah, so you see this is just one block, so we're going to get the same hash, and then it's got the values from the transactions. So this is cool. You can start to do stuff that's joining multiple different documents. And wow, should I try to write this in SQL? I guess I will. I'm questioning my desire to do that. I think I'll just talk through it first, because I only have like 10 minutes left here, and maybe it'd be interesting to start doing something else. So the way this is working is what's called unification, which just means that the query execution engine is going to look at this query, and it's going to try to find every case where we have something like this question mark t, and put the same value into there. So it's going to find a unique set of values that satisfies the constraint that all these things with the same name are equal. You know what? I'll go ahead and do it. So it'd be like, I probably shouldn't have used blocks or docs in the first one, because that confuses things a little bit. Let's just think of these things as independent tables, even though in Crux's view, they're all sort of the same kind of thing. They're all documents. So this would be block and tx dot, what are we pulling out? Data size. So it'd be equivalent to this. So blocks B, we have tx's, let's just call it t, and we're going to join blocks B on B dot, what are we doing? Indep hash. I mean, you could also do this like ID, but this is a little more explicit. So it's like the independent hash of the block is equivalent to the block indep hash on the transaction. And that's really it. So here, the difference between the way Datalog works and the way SQL works is SQL, you can see, is much more verbose in the way you have to express this. Well, a couple differences actually, but in SQL you have to tell it, okay, this thing equals this thing. In Datalog, you just tell it, okay, this is the same as this. Like fill in the blanks. These two things are equivalent. But in SQL, it's a little bit more explicit how you're joining. The other thing that's different than SQL is this style of data log. We're dealing with triples, so sort of like RDF style or semantic web style, where you have an entity, that's the thing here. You have an attribute, that's the middle thing, and then you have a value. So it's kind of like you took a table and for each column you made it a separate thing. So the columns essentially become the attributes, and that's why there's some relationship between like this kind of storage and column storage. Although underneath column stores, analytic column stores, I should say, actually organize the data fairly differently, but they do store the columns independently, and that's kind of the way that the indexes in Crux works, where each of the attributes kind of ends up as its own thing in the index. Not the most detailed explanation there, but yeah, I think I'll leave it at that. Maybe if we revisit this, I'll try to go into a little more detail with some diagrams of like how this maps together. But hopefully that makes sense. Instead of a wide thing, you have sort of a vertically tall thing in this kind of query. Yeah, so I'm trying to think if there's anything else that would be cool to go into. Like, I think I will wrap up here at the end of the hour and keep this one to an hour, because Open Web Foundry is starting in 5 minutes, and I think I'll probably go. and this is a fairly good stopping place. So I guess in the last minute or two here, I don't know if I'll get to this in a future stream, maybe, maybe not. Um, I guess playing around with this data once I have more of this structure built out would be a pretty fun thing to do for a stream. So yeah, I may revisit that. I think one thing that would be cool that I actually had in my notes would be like taking some queries that you would send to the GraphQL endpoint for Arweave and turning them into data log queries just to see what that looks like, and just to see how those execute against this data structure. Um, but the next thing I would probably do here, let me turn this back into the for loop and print that out again. So other than I shouldn't call that a loop. It's not really a loop, but whatever. It's a list comprehension. The next thing I'll probably do, like the next two things I'll probably do myself, is like start converting these values. So take the base64 URL encoded stuff, turn it into bytes. Take all the integery things and turn them into big ints. And then the next thing after that would be to take the tags out and start turning this into another document structure so that you can query that whole thing. I'm still debating a little bit. I'll have to look at how Crux stores things, but I suspect. Yeah, I'll just have to look at it in more detail. I don't know if it might make sense to take these name values and turn them into documents that have their own identities. You might end up with a smaller, and then use those in the queries. You might end up with like smaller total index sizes with that. And the size is not important because of the amount you spend on storage. It's important because when you query indexes, size is basically, assuming that your data is assuming that you're not seeking all over the index and that you can find the data in the index quickly, the size of the index is equivalent, says something about the amount of I/O you're going to do, and that impacts performance. Of course, it assumes that your index is sorted in a way that's useful for your queries, but given that assumption, that is the case. So yeah, I'll have to dig into the Crux code a little bit and see which way actually makes sense, or maybe just run some queries too, just do some benchmarking. But yeah, I think I'll wrap it up there. I'm pretty happy with this. We got a block in, we got some transactions in, we did a join on them. Next thing from my perspective is just filling out the rest of this data structure, getting things into the right types, and then it actually should be pretty easy for me to hook this up to my analytics, and I think it will both improve the performance of the analytics I'm running because I'm doing some fairly naive things, and it will let me use Arweave itself as the source of those analytics in the future while still giving me a lot of query power. So I think that will all be good. So thanks for showing up if you listened, and I will talk to you next week. Later. Have a good weekend.